noxious, toxic, poisonous, hazardous, carcinogenic, contaminative, radioactive, flammable, explosive, fungicidal, corrosive, bactericidal, insecticidal, asphyxiant. These are just some of the terms used when talking about chemicals, and they conjure up notions of many unpleasant things: cancer, dermatitis, long-term illness, fires and explosions, and so on. There are two things we should all understand about chemicals. Firstly, there's no such thing as a harmless chemical, and secondly, there's a safe way of handling and using all chemicals. A chemical can be a solid, liquid, or a gas, and it can combine with other chemicals to form chemical compounds. Chemicals are a fact of life. All living things are made from chemicals, and in fact we depend upon chemistry for our very existence. Everything from the ground that we walk on to the air we breathe is made from chemicals and chemical compounds. Everybody knows that lead is poisonous. However, the only way this piece of lead can harm you is if you drop it on yourself. The physical form of a substance is critical in evaluating a potential risk. A chemical that's safe in solid form may be toxic or flammable in a vaporous state, or give off hazardous fumes in a liquid form. The way a chemical is used, the conditions under which it is used, and frequency of use are also factors which influence the risk of harm due to the hazards associated with a chemical. How much of a substance comes into contact with the body will determine the potential ill effects. An extremely toxic substance in a small enough dose may have no harmful effect, while a common, naturally occurring substance found in food, if taken in large enough doses, can indeed be harmful. Now let's start to put some of the facts together. A chemical can only be harmful in one of three ways. It can contribute to cause a fire or explosion, it can come into contact with the body, or it can enter the body. In the workplace, chemicals can enter the body in one of three ways. Inhalation, that is breathing chemicals into the lungs, which, by the way, is the most common form of entry. Through the body, either by coming in contact with the eyes or through the skin, or by ingestion, either from eating or drinking. So now it follows that chemicals have to be present in the appropriate form to enter the body. To enter the lungs, a substance must be in the form of smoke, fumes, mist, dust, or vapor. To enter through the skin, it must be in a form that can be absorbed through the skin, and therefore in most cases is either a vapor, liquid, spray, or mist. A chemical absorbed into the body may cause acute or chronic poisoning, or in some cases both, or alternatively have no harmful effect at all. It might also show no harmful effect in small doses. However, many small doses might produce a cumulative effect and lead to a slow-forming illness. Corrosives usually affect the mouth, nose and throat and cause inflammation and irritation. In high concentrations, they can also cause severe burns, and in the form of fumes, for example acid fumes, can be extremely hazardous. Allergens can lead to things like dermatitis and asthma. These reactions become more serious with repeated exposures and affect people in different ways. A chemical which causes dermatitis in one person may appear to have no effect on another. Carcinogens are obviously capable of causing cancer. The dose required depends on the chemical and how it is used and absorbed into the body. Mutagens can change the genetic code of cells, and teratogens can affect the growth of the fertilized egg and the embryo. So, there are indeed many different chemicals and chemical compounds. Some relatively safe, some that present a hazard to certain people, and some that present a hazard to everyone. On top of the health hazards that we have just looked at, there are two other major hazards that make chemicals such an important issue in occupational health and safety. They are environmental pollution and, of course, fire. Because in most cases fire occurs when flammable vapor is given off from a substance and is in the presence of oxygen and a source of ignition, the physical form of the material is again very important. Obviously, flammable gases, which are already in a vaporous state,
are more hazardous than combustible solids. A liquid which gives off a flammable vapour is a fire hazard, but if its surface area is increased, for instance by being in a larger container, the problem can be significantly greater. Simply put, we can have a much bigger fire from the same amount of fuel. Dust and fibre deposits can lead to explosions and are real hazards in mills and similar work areas. They can also act as extremely efficient sources of fuel and can rapidly spread a fire.
The temperature of the substance and the availability of oxygen are two crucial ingredients when evaluating potential fire hazards. If these factors are considered along with containerisation and separation, many of the hazards can at least be reduced.
Environmental pollution can occur when a chemical is released into the environment in an uncontrolled manner. Commonly, this falls into two categories: spills and leaks, and air contamination. Both can happen inside the work area or in the outside environment. Damage to the environment, sources of fuel for fires and health hazards from air contaminants, are the problems that arise from pollution.
The first step in controlling hazards is to understand them. And in the case of chemicals, this can be a major problem. Not only do we need information about the particular substance we are using, but also we need to know what happens when we combine one or more substances in a process or product, and the resulting properties of byproducts and finished products. The starting point for this process is combining information such as material safety data sheets with the experience of trained personnel in the workplace. Well, what are some of the steps we should consider?
Firstly, we may be able to eliminate the use of some chemicals completely, and we can ask the question, is this chemical actually needed? We should evaluate each process or activity and identify hazardous chemicals, and then try to substitute a less hazardous chemical that will perform the same task. An example would be replacing benzene with toluene.
We can also look at the way a chemical is used. For example, a spray process may be replaced with a dipping process.
Substitution of the container a chemical is supplied into a safety canister is another consideration. And this leads us into the very important area of labelling. All containers should include the product name and the name of the manufacturer. Warning symbols and details of the ingredients should also be present on the original container. Having the name of the product on any storage container at least allows for reference back to a chemical register. The other factor we must remember about labelling is to make sure we never transfer a chemical into a container that is contaminated or identified as another chemical or product. Isolation of a hazardous process by either enclosing the activity or the operator is another often used and effective control measure. Distance from other work areas can also isolate a particular process. Ventilation can remove airborne contaminants, ensure an adequate supply of oxygen, and help prevent fires by removing flammable vapours. Ventilation units can be permanent installations or portable units. Monitoring of contaminant levels in the air can be used to make sure that exposure to chemicals is within acceptable levels. Regular medical screening might also be considered if the work environment is regarded as a high risk. Personal hygiene when handling chemicals should be a part of any safe work procedure established in your workplace. Included in this regime could be regular changes of clothes, use of barrier creams and gloves, and regular washing of hands and forearms, especially before eating and drinking. Good housekeeping, in particular cleaning and decontaminating surfaces, is another of the everyday control measures which helps to make working with chemicals less hazardous. The wearing of personal protective equipment such as aprons, gloves, goggles, face shields, respirators and footwear often serve as a backup and a last line of defence should an accident occur. However, some activities in the workplace present high risks, such as entering confined spaces, and the wearing of personal protective equipment can be of paramount importance. Jobs of short duration, which are only performed occasionally, jobs performed in different locations, jobs where contact with a chemical is required, are all examples of where the use of protective equipment may be required. Signposting helps in identifying some of these situations, as well as acting to provide permanent warning to high-risk areas. These signs must be obeyed by all personnel, as well as any visitors or contractors.
There are many ways of controlling the hazards when dealing with chemicals. The best of these methods should be to make sure that the safe work procedure laid down for performing a particular job or task is strictly adhered to. These procedures have been set by experienced personnel and take into consideration all the risks and hazards that may exist.
The overrider to this is that processes do change. Chemical substitutes may be introduced, new equipment may be installed. So if there has been some change in a particular job, or you have a concern, raise it and discuss it with your supervisor, safety committee or safety manager.
There are a number of questions we must ask when considering how chemicals should be stored. Let's take the opportunity to take a brief look at some of these questions. It's a complicated and specialised area of expertise. However, an understanding of some of the fundamental questions will highlight the importance of following the correct practices.
Should access to the chemical be controlled by being placed in a locked area? Is the chemical subject to change at different temperatures? Is it therefore necessary to store it in a controlled temperature environment? How much of a particular chemical is safe to store in one location? Are particular combinations of chemicals safe to store together? Is the storage area in a suitable location, for example, away from food or away from possible sources of ignition? Does the storage area need to be well ventilated? Do the storage containers need to be kept dry at all times? Is it necessary to store a particular liquid in abundant storage area to contain a spill or leak? When transporting chemicals, as well as addressing many of the same sort of problems that apply to storage, we have the added requirement of identifying dangerous goods and making certain the required signs are displayed during transportation. This is in many cases a legal requirement.
Should any of the following situations arise, there may be a problem that has not been recognised or properly addressed.
People suffering from irritation to the eyes, nose, throat or skin. The presence of strong or unpleasant smells. Clouds of smoke, dust or fumes. Excessive amounts of dust on work benches or floors. Also, should a chemical be required which is not often used, or a new chemical introduced, there may be strict handling or storage requirements that could introduce a new hazard to a particular work area.
Chemicals are used in every workplace. The safe handling and storage of all chemicals, regardless of where they are used, requires a commitment by everyone to follow safe work procedures. The realisation of the risks and an ongoing program to minimise the hazards will reduce accidents and make your workplace a safer workplace.